Hello, welcome to part 2 of the cheap-ass quadcopter build. In this video we're going to take a look at the parts that we're going to use. Sorry it's taken so long to get this video done. I had of course wanted to get it uploaded much sooner, but as you may recall from the last video I'd been having quite a bit of trouble finding some nice joysticks to use. I eventually gave up on the first set of joysticks I had, and I searched around and found some alternatives and ordered those, and I'd been waiting for them to arrive so that I could test them properly. In the meantime, the first video had generated quite a bit of interest, although I shouldn't say it had generated the interest on its own. It had quite a bit of help. Thank you, Julian. And I think it might have been one of the comments on Julian's video that got me looking in a completely different direction for transmitter options than I had been previously. And what I ended up with was something that is not only cheaper than the original plan, but is also much less work to put together. And for those that are not really interested in Arduino coding and the radio module and such, it should also be a much more attractive option for them as well. So to cut to the chase, what I'm talking about is a complete backtrack from making your own transmitter box like this, although it is great for novelty value, isn't it? And I did actually get this working quite nicely once I found some potentiometers that had no dead zone. But in the interests of practicality and, surprisingly as it turns out, actually cheaper, I think this is something that I'm more comfortable with recommending, because this lets us use the transmitter without actually having to do any Arduino programming at all. And there's also some nice features like we already have a battery case, we already have nice joysticks, power switch, LED to tell us that it's on or off, switches on top here, analog dials, all for the shockingly cheap price of $25. So this is the plan. So I'm going to end up making two slightly different sets of videos. Well, sorry, no, one set of videos with a little addendum I'm going to have to make at the end, because I do actually want to wire this up inside to use the NRF24 radio modules still, but I will also of course explain how to set up this receiver to fly the quadcopter as well. So hopefully this is something that'll be a bit more useful for the majority of people who are just not really interested in Arduino programming so much as they just want to get something up and flying. So I've had to split up the spreadsheet that we had before into two spreadsheets. The links are in the description. So the first one will be using the HobbyKing transmitter only, and the second one will be using NRF24L01 and Arduino. And fortunately the prices have come down from around about $200 down to $160 if you're just using the HobbyKing transmitter. It's nice and cheap. And if you still want to do the NRF24 with Arduino, you're looking at about $179. Plus HobbyKing shipping cost. I think that might depend on where you live. So for the Arduino one, you'll see that the HobbyKing transmitter is still in here. Basically this thing is cheap enough that you could buy it and not ever use it with the receiver that it came with. So what I'm intending to do later on is just to wire up my Arduino and my radio module inside this transmitter box and just use it for the joysticks, basically. The joysticks, the switches, and the dials on the front. And it's cheap enough that it's still worth buying that if that's all you're going to do with it. And I guess I should mention at this point, because the question will be coming up, what is the point of still using the NRF24L01 and Arduino at all in that case? Well, the point for me, and for anyone who might be interested in it, is that you can send a lot more variety of information using those radio modules than you can with just a normal RC transmitter. So if you're just interested in making a quadcopter and flying it yourself, there's no point using this radio module and Arduino, especially if you don't know anything about Arduino to begin with. But as I mentioned in the first video, the whole point of what got me interested in this stuff in the first place was the fact that quadcopters could be controlled by computer control. And since I'm a programmer by trade, that's what took my interest. Flying radio controlled quadcopters is fun and everything, but it wasn't really that got me started on this whole course of stuff that I've been doing. So that's just a bit of background about that. And if you're going to be doing stuff like that, as I'm going to be doing, computer control, I want to send GPS coordinates backwards and forwards between the transmitter and the quadcopter and stuff. There's just no way you're going to be able to do that with the regular transmitter. So that's why I still want to use the NRF24 modules and Arduino and so on. Alright, so let's look at all the bits and pieces we're going to use. I'm not going to say too much about the frame because that's up to you really how you design that. I made a so-called H frame from wood, and you can copy that design if you like. It's pretty simple, nice and easy, and gives you lots of space to mount things on. However, I wanted to say a little bit about the wood. If you do go that wooden frame route, this is the wood that I used here. It's 15mm square balsa, and I would not recommend this. It's just too soft. It's nice and light, but it's very, very soft, and if you're going to strap things around it with zip ties, it's not the greatest. What I would do instead, and what I probably will do next time, is use this piece here, and this is some kind of cypress, I think, and it's 12mm square, 10 yen cheaper, look at that. And yeah, it's a lot harder, and if you watch the flight test channel, this is what they use, and obviously they know what they're doing, don't they? So balsa, probably not the greatest. Some other kind of hardwood would be better. These are the motors that I've listed in the spreadsheet. I chose these ones basically because they were the cheapest I could find that were in the right kind of size range. So you'll want something that is around about this size, not too much bigger or smaller. The numbers on the side there, just by the way, it took me a while to figure out what these numbers mean, so I'll just mention them just in case anyone's interested. The 18 means that the stator diameter, so that's roughly from the green pieces on either side there in the photo, is 18mm. The 04 is the height of the stator, so that's the vertical height of the side of the motor. That's 4mm. And then the 2400 kV, kV means thousands of RPM per volt. So if you applied about the 2S voltage of 7.4 volts to this motor, it will spin at something like 18,000 RPM. Now, I've been using these motors for quite a few months now, and I haven't had any problems with them, although I have heard that some people have struck some issues, so perhaps there are some bad batches out there. I don't really know. The issues seem to be that the outer part of the motor can slide up and down on the shaft quite a bit, and actually one of my motors does do that, but I haven't noticed it to be an issue when I'm flying. These motors are available with both clockwise and counterclockwise threading on the output shaft, which is quite convenient because you can use that threading to help the prop fastener stay fastened as it's spinning. And the diameter of the output shaft is 5mm, which is quite convenient because most of the cheap Gemfan plastic propellers that you can buy have an inside diameter of 5mm where you mount the propeller. And they do come with some inserts that you can use if the output shaft of the motor is narrower, but it's just a lot more convenient not to have to bother with that kind of adjustment. The ESCs that I've listed come in a set with the motors, so they are kind of, again, the cheapest option I could find. They are rated at 10 amps, although I bought some other speed controllers which were 12 amps, and they were much bigger than these ones. So I'm not sure if these are really 10 amps or not. So far they seem to manage perfectly well with the 2S or 3S battery, although I haven't really put them through their paces with the 3S battery very much. So could be that if you did a lot of fast accelerations with 3S batteries, I don't know. But definitely with 2S battery they're perfectly fine. This is the so-called power distribution board that I've used. This is not strictly necessary. You could just sort of clump all the wires together and solder them up in a big globby mess, and it would work perfectly well. But this is just one way of keeping things a bit tidier and gives you some nice pads to solder onto. The flight controller I've used is this one here. It's an IC Station branded multi-Wii board, and I've used this one for a few reasons. The first reason, which I should probably mention, is that they sent it to me to do a review on. But wait a minute. I probably would have got this one anyway, because it seems to be the cheapest one out there, at least that I could come across, at $15 when I got it, or $16 I think at the moment. And it's not likely to be found anywhere much cheaper than that, because if we take a look at what's on here, it's basically an Arduino Pro Mini with some sensors: accelerometer, gyroscope, compass, and barometer. And I did a video a little while ago where I used this exact same combination of components in basically an Arduino Pro Mini: accelerometer, gyroscope, compass, and barometer. And each one of those things that I used there, the Arduino Pro Mini was about $4 or $5, and the sensor board module was about $11 to $12. So basically, if you put those two costs together, you're looking at about $15, $16 anyway. However, if you get them separately, then you have to go through the hassle of connecting them, wiring them up, and getting them all working together. Whereas if you get them on this multi-Wii flight controller board, it's all on the same board, nice and easy to mount in a nice square package, and you even have some pin headers on there ready to go. To get the multi-Wii software uploaded from your computer onto the flight controller board, you'll need one of these FTDI adapters. And once again, if you're at all familiar with Arduino, you may probably even have one of these already. But basically, you plug a USB plug into one side, and the other side has 4 wires, I think is all we need in this case. And you plug those 4 wires into the appropriate spots on the flight controller board, and you upload the flight controller program with that. The transmitter box, as we looked at briefly just a minute ago, is this one here, and it's labeled as a 6-channel transmitter, but there are actually 2, 4, 5, 6, 7, 8 channels worth of inputs that we could use on here. So presumably that's what the computer programmable label means there. So perhaps you can connect this to a computer to set up which of these channels at the top that you want to use for the 5th and 6th channels. I actually don't know how you could do that, because there's absolutely no documentation that came with this at all. But presumably you can connect with this somehow. I don't really know. I don't really see any other way that you could connect this to a computer. There's a charging jack on here, which is quite convenient because you can use your LiPo battery charger to charge the battery pack. It takes 8 AA batteries. And yeah, like I say, it's set up to be 6 channels to start with. But if you're going to be setting this up to run using the Arduino and the RF24 modules, we can use all 8 of these channels, no problem, and many more. The battery alarm that I've mentioned in the spreadsheet is this one. It can take up to a 3-cell LiPo battery, and it's not really necessary to have one of these to fly, but it's highly recommended that you do have some kind of alarm like this on the quad as you're flying to check the voltage of each cell, because if you discharge them too far, you can damage them permanently. This is the battery charger that I'm using. It seems to be a fake, a clone of another brand, but seems to work okay for the most part. It has a maximum power output of 50 watts, so it's not really good for charging any of those mammoth 10,000 milliamp hour batteries or anything. But for the kind of smallish batteries that you're likely to be using with this quad, it should be just fine. It's able to charge a number of different battery types, so you can actually use this to charge your transmitter battery pack as well if you're using nickel metal hydride batteries or something like that. Now, I have seen some people saying that this charger has issues. Once again, I seem to have been quite lucky in that my one seems to be pretty much okay. But yeah, this, as I mentioned in the spreadsheet, if you want to spend a bit more money on something, this is probably the first thing that I would upgrade. As for batteries themselves, you'll probably end up with quite a bunch of batteries if you get into this hobby in any way. But if I had to recommend just one battery from all the ones I've tried so far, it would probably be this one, I think. And definitely for this size of quad, it seems like around about a 2-cell 1300 milliamp hour battery is quite a nice balance of flight time and power. So this is what I would go for as a first battery if you're getting one to start with. And I think this is the one that I've listed on the spreadsheet actually. However, just a minute. If you buy things from Banggood, I've noticed that the shipping times for LiPo batteries are very, very long. I live in Japan, which is pretty close to China, and I tend to get most of my stuff from Banggood in about 8 days, roughly, except for LiPo batteries, which take 6 weeks. So when it comes to batteries, you might actually want to just find them in a local shop near you instead of ordering them online. So it's just one thing to keep in mind. To connect things up, you'll probably find that the easiest way is to use some of these female to female jumper wires. They're pretty cheap. You can get a packet of 40 for a couple of dollars. You'll need 4 of these to connect your FTDI adapter to the flight controller. And I also found them very useful to connect the flight controller to the Pro Mini and so on, just by soldering some pin headers and make them stand straight up. And then you can just connect everything by plugging in wires. Makes it quite easy to set everything up. Not very robust for a long-term solution, but actually I've found that I could crash a few times with this and nothing seemed to come disconnected. Now, we all know what zip ties are, I hope, but I thought I would just mention that if you're doing the same kind of frame design as I have, where I'm using zip ties to strap the motors onto a beam of wood, you will want to get some zip ties that are quite narrow. They'll have to be 2 millimeters wide or less if you want to fit them underneath the little mounts on the bottom of the motors. Okay, so if you're just using the HobbyKing transmitter box with the standard receiver as is, that's all the stuff you'll need. If you want to use the RF24 radio modules and the Arduino connection, I'll just mention those pieces. They are, of course, an Arduino Pro Mini. This is actually a 5-volt one here, but we'll be using the 3-volt one. Oh, you need 2 of these. And then we need 1 high-power RF24 module for the transmitter. I find it easier to use this type here, which has a little snap-on connector for the antenna instead of having the whole antenna mount directly mounted onto the PCB. It just gives you more flexibility in where you want to mount the antenna on your transmitter. And then of course we need another RF24 module for the receiver. This one is not going to be doing any transmitting, so it doesn't need to be the high power type. It can just be the normal regular PCB antenna type. Now the RF24 module on the transmitter, the high power one, has been a little bit of a tricky thing to provide power for properly, I've found so far. And what I've been using is one of these DC to DC step-down voltage regulators to give power to either to that module directly or to step down the voltage before giving it to the Pro Mini, and then using the VCC pin on the Pro Mini to provide a nice smooth 3.3 volts to the RF24 module. And I'll get into the details of this in a later video, but suffice to say for now that this is the part that I've been using here, and this is the one mentioned in the spreadsheet. And finally, we need an antenna for the transmitter. I've been using these rubber duck type antennas, and they seem to work just fine. By the way, if anyone is actually interested in making their own transmitter box completely from scratch, as I had done originally, I'll just mention here the joysticks that I found that did actually work quite nicely. Surprisingly nicely, actually. I found it pretty much as easy to control the quadcopter with these joysticks as I did with the actual transmitter that I was using before. So I'll just put a screenshot up of where I got these from, and it should be pretty obvious from the screenshot where you can find them. and they're very cheap. So that is one nice thing about them. So that pretty much covers all of the parts that I've used. There's a few other little bits and pieces like sellotape and rubber bands and little things like that that I didn't mention here, but you should be able to find that in your local area, and I don't think there's anything else that you would need to be ordering online. Just before I finish this video, I'll quickly go over the tools that I needed to get this job done so that you can get an idea of what you'll need to be prepared with before you start. So I used a craft knife or a box cutter, whatever you want to call that thing, a pair of side cutters, a pair of pliers, a pair of wire strippers, or you can use your teeth or your fingers if you're good at that, some small screwdrivers, a soldering iron, and you don't want a soldering iron that's too fat because you're going to be doing some quite fine soldering. This one that I have is kind of like a sharpened pencil at the tip. It's about the same size as a sharpened pencil. Of course, you'll need some solder, and you might find yourself wanting to unsolder things occasionally, and if you do that, it's really handy to have a solder sucker, which makes things quick. Although it's not really necessary, you can also use solder wick, which works pretty well too, but it's a little bit slower. You'll need a multimeter to dial in the right voltage on your DC to DC step-down voltage regulator. It's handy to have some tweezers and little clamps and things. I used a lighter to tighten up the heat shrink. Just be careful that if you're building a wooden frame. And speaking of wooden frames, if you do go the route of making a frame from wood, you'll probably find yourself needing some of these kind of tools here. I'm pretty sure this is everything that I needed to use. Well, that brings us to the end of this video. In the next video, I'm going to get started building the frame. Well, I actually made it almost 2 months ago now, so I'm going to upload the video that I took from when I was building the frame, I should say. And I made that video before I got this nice microphone that I'm using to record this video. So the rest of the videos in this series are going to be recorded with my Nexus 7, so the audio is going to be a little bit more scratchy than this, but hopefully you can endure through it and it won't be too much of a trouble. So anyway, I'll see you in the next video.